Okay, in this video I'm just going to give a really basic introduction to RTran. I'm not going to go into any detail really, I'm just going to give the really basic idea about what it is at a very, very high level. I'm going to assume at this point that you've installed RTran successfully and run it at least once with the default sort of input file, and so you've verified that it runs okay. And now I'm just going to talk about the software. So really what drives the whole simulation, so there's basically two parts to RTran. There's the core simulation engine, which will run a transport or simulate a particular transport system, and there's an input file that you need to specify, which basically says what the transport system is. It says, you know, what the road speeds are, whether there's any public transport routes, and what the fares are on those transport routes, and that sort of thing. So that input file is really where you specify what you'd like to, the sort of scenario that you'd like to simulate. So let's open that now and have a look. So that always has to be called user input. It's an Excel file, as you see here, and it's user input. So let's open that. And that's always what RTran looks for when it starts up. It reads in that file, and that's what tells RTran what to simulate. So I've opened user input, and I'm not going to talk individually about these parameters yet. I'm just going to give you the basic idea that I might talk about one or two just to give you the idea. But before I talk about this sheet, I'm going to talk about some other sheets. So you see in this whole spreadsheet, there's a number of different sheets, and I'll just pick one. I'll pick the trips sheet. So RTran is simulating a particular, think about it as a city. It could be smaller than a city, or it could be, in principle, be larger, but it's simulating some region, and you need to specify a whole bunch of information about that region for RTran to actually run properly. So this particular sheet that I've selected is trips, and you see here there's a whole bunch of cells with numbers in them. So there's actually, if we look back, there's 20 cells by 20 cells. So that means for this particular simulation there's 400 zones. So think about each one of these cells as a particular zone in a city, let's say, that you're simulating. The trips sheet, this particular sheet, is where you specify how many trips there are from each zone. So I'll just pick one here, let's say. So at x equals 1, y equals 10, there's 1,422 trips that originate from this zone. And that's just an input. So I can make that whatever I like. I can change that to 2 if I want to. Specify however I like, depending on what my city or region looks like. And there's nothing magical, there's nothing going on in this spreadsheet. You can just type over these numbers themselves. You can see I've actually used a formula to calculate, you know, something like that's nice here, but you can just type in raw numbers if that's what you want to do, whatever. You just need to specify however you like in Excel, in this case, how many trips there are. And there are a bunch of other sheets as well, and I'm not going to talk individually about those sheets because I'll do that in a separate video. But for now, you just need to understand that in the spreadsheet, you're setting up the simulation. So here, in this sheet, it's called car speeds. This is specifying the speed in kilometers per hour in each zone. And for this example, I've just made it really easy, and I've said this is in each zone you travel by car at 40 kilometers an hour. That's the uncongested speed within each zone. And I won't talk about more of the inputs. That should basically give you the idea, though, about that, about what this user input file is for. It's for you to specify what the simulation should do, what the spatial structure of the city or region you're simulating is, some information about the speeds by car, some information about trip generation, where those trips might be going to, and some information about the public transport routes. I haven't showed the public transport routes, so maybe I just better do that quickly. So I'll click on train frequency. So here, again, I've made it simple just for this case. There's one train line, and you can see it runs up here, across here, and up here. So that's where it runs through our city. And the 10 up the top here says that it runs at a frequency of 10 services an hour, so it's pretty frequent. So there's only one train line, but it runs pretty frequently, 10 services an hour. And you specify the speeds in a separate file. So the train line runs at a speed of 60 kilometers per hour. So it's faster than the cars in this case. So you can specify much more complicated train routes, and you need to do also bus routes, which I won't show the bus routes here because this is just a general overview. But basic idea is this user input sets up everything. It's the input file that tells ArtRAN what to simulate. So I'm going to close out of that now. Hopefully that's clear. And I'm actually going to open the GIS file again. The outputs basically. So I showed you how to do this before. So I haven't run I've run the simulation previously. So basically, all the outputs are still saved. And if you changed your input, you'd need to run ArtRAN again, and it would generate all the output files. But because I've run ArtRAN previously, I don't need to do that. I'm just going to double-click Run GIS and have a look at some of the output files. And I'll talk just in a little bit more detail about those, because they're probably nicer to look at in the little GIS program. So again, as I mentioned before, it takes a while to open just because it has to read in so many files, because ArtRAN generates a lot of output files. But it should be finishing pretty soon now, and we should get our window pop up. And here it comes. There it is. Okay, so this is the mini GIS program that lets you view the outputs. You can also view the inputs that you specified to run the program. So if you notice, really the only thing that you use in this GIS program is the view menu. So if you click on view and you go down to inputs, this should show you what you specified in your input file, basically to remind you. So if you remember when we looked, there was one train line and it was running at 60 kilometers an hour. So if we click on mainline speed, we should get, it's one line, it's in the same configuration that we specified. And whenever you choose a particular view, or particular data to view from the view menu, you'll also get a box popping up which shows you what the scale is on that map. So in this case, the scale is from deep blue to deep red, where deep red is 60 kilometers an hour. And if you remember when we just looked at the input file, our train was specified to run at 60 kilometers an hour along this route. And everywhere else it's 0 because there is no train service there. So you can look in there at your inputs, but the other one that we looked at in this Excel spreadsheet was the trips from, or the trips, and that's what it looks like. So the scale there. So that's just pretty uninteresting. It's recreating what we fed into the simulator. More interesting are the outputs. So generally you won't be concerned so much with the inputs unless you just wanted to check what you specified or have a look at it. More interesting are the outputs. So there's a lot of output tables generated, and I'll talk in more detail in the subsequent video about them. But for now, hopefully most of them should be fairly self-explanatory. So for example, trip length, one way. You can get the trip length by car, let's say in this case. So if you go trip length, car, select that. It's showing you the trip length by car from each zone. And you see here that right on the outskirts of the region we're simulating, the trip length's longer, it's the red scale, and right in the centre it's shorter. So people in the centre are making shorter trips than people on the outside of the city. And so that's by car, so that's trip lengths by car, but we could do combined trip lengths. So combined trip lengths, this is by all modes, by combined I mean. So this is the average trip length across all modes. And we see that it's a similar sort of pattern to by car. Maybe let's look at another trip length by train, let's say. Now that one's not such a neat pattern, and that's because of the structure of the train line. So you may remember from our input file, we had a train line running here, across here, and up here. And so obviously the people that live at the ends of the train line are tending to make longer trips by train. And that's why we have these dark numbers here. And the people in these regions where it's blue, they don't actually live near the train. So if they do end up catching a train, like some of them will catch a train sometimes, they're not going to be usually taking a long trip. So that's why it's shorter for these guys. So people on the train line will be taking longer trips by train when they take a trip by train. The reason for the checkerboardy sort of pattern along the train line is actually to do with the bus routes that I've specified in this particular simulation. So it does make sense if you look at the bus route structure, but for now this is just to show you that the train line does show up, the structure of the train line. If we look at passengers, so let's look at mode share by origin. So for all the trips, we'll look at the mode share by origin car. So here, again, whenever we select a table, a scale window pops up, and it shows us that at the bottom end of the scale, 64.6% of trips are by car, and at the upper end of the scale, it's 77.2% of trips by car. And we see sort of a checkerboard pattern. Again, that's to do with the public transport routes that I've specified in this, but we see car tends to be, as you get further away from the city, there's more people taking car, and as you get closer in, there's fewer. But car in this particular example is still the predominant mode of transport. Okay, so that's probably where I'll stop now. All I wanted to communicate through this video is to show you that RTran runs off an input file that you specify. That is quite detailed because you need to specify exactly what you want to be simulating, so down to the level of individual bus routes and train routes, and down to the spatial structure of the city, sort of where the trips are coming from, a bunch of other parameters too, which I'll talk about in more detail. But once you've done that, RTran will run the simulation, and you can look at the outputs in a lot of detail. So just to give you an idea, I'll use accessibility. So overall accessibility, we'll look at what that looks like. So unsurprisingly, the people within the center of the city here have much higher accessibility than people further out. So basically, the definition of accessibility in the software is the number of activities that people can reach within a fixed sort of time and money budget. So I'll explain exactly what I mean by that later, but for now, this is just think warmer colours means those people in the warmer regions can reach more activities more quickly than people in the sort of cooler colours further out. Okay, so I'll shut that down now and end the video, and in future videos I'll talk in a little bit more detail about go into more detail about the inputs and how to set up the city, so we'll go through that.